Hi, welcome everyone. My name is Dr. Kiyo Wada. I'm from the Aerospace Engineering portfolio of Swansea University. I'd like to go through some of the quick introduction to what we have for the aerospace engineering, and I hope that will give you some ideas and a quick overview to our programs. So let me go to the slides. So basically what I like to talk about is all to do with this why aerospace engineering at Swansea University. So the following slides, I hope to give you the answer to this basic question, why aerospace engineering at Swansea University. So first and foremost, we do have this world-leading research as a backing to our aerospace engineering. We do have a traditional and long partnership with Rolls-Royce. We do have this Rolls-Royce University Technology Center on site at a campus. And we do have a lot of R&D, research and development program with Rolls-Royce. Along with that, we do have other research programs with Airbus, BAE Systems, GE Aviation, and so on to work on these futuristic ideas about materials, ideas about those aerodynamics and so on with regards to aerospace. And we do have some of their iconic programs such as LADHAM project that's been running over 10 years. And some of our staff members have been involved with this iconic LADHAM project, for example. And based on that, we run quite well in terms of graduate prospectus, as you can see, UK top 5. And with regards to the teaching aspects, of course, we do have TEF Gold. So we do have some kind of recognition, not just for the research, but also for the teaching and learning. So I mentioned about our league table standings. This is a quick overview with regards to Times Good University Guide and the Complete University Guide. So we do have rankings, let's say top 10 in the UK. And we do have high rankings for the graduate prospectus within the top 5, as you can see. So we're aiming to, of course, reach higher in these rankings from this year and also onwards to making some sort of a leading sort of research and also leading in the aspects of student satisfaction. Alongside the rankings, of course, so we do have good sort of reputations and good recognition in terms of employability. We do send those university graduates who do study aerospace, and they do enter into the various industries in the UK and beyond. And we do have, let's say, 94% of the employability for aerospace. So we do teach and train those university students who does aerospace to ensure that they learn the knowledge, they have acquired the skills that they need for the industry, and they have a high probability and chances to work in the various fields of our industry. And some of them, of course, ended up going to the postgraduate programs such as PhD and InchD. In terms of our degree curriculum, we do have this MEng, Integrated Masters for 4 years, and BEng for 3 years. We do have options such as a foundation year. If you were to do a foundation year before you enter into MEng or BEng, we do have options such as that. Or we do have a year in industry or year abroad program, so you can take a year out to industry or in abroad to take some sort of a broader vision and perspective into your learning programs and come back in to complete your BEng or MEng. Those BEng and MEng curriculums are accredited by the professional bodies such as IMechE, RAES, IET. Some of their postgraduate MEng, MSc program modules is being accredited by the Association for Project Management, APM. So that this slide here shows sort of a flow chart, let's say, with regards to BEng and MEng. So as you start on your BEng, MEng program, we start from the year 1. This will be the same for whether you start from BEng or MEng. So as you continue to year two, you may like to consider going to a partner university in the US. We do have a partner university in the Texas A&M. So some students do take 1 semester. Some people take maybe 2 semesters to do their year two program with our partner university in the US and complete that year program over there, and then come back in to continue with their study at Swansea University. If you take an option as to do in industry or in abroad, generally speaking, you may do so after completing your year two, and in between, you take a year out to those industries or in abroad to do your placements. And as you complete, then you come back in to continue with your year three, and then you graduate for the BEng program. But for the MEng program, you continue to your 4th year level, and then you graduate at the end of your 4th or 5th year, depending on your options. So what do you study for aerospace? In a nutshell, if I can summarize, you may become versatile with the knowledge. Those knowledge can be aerodynamics, fluid thermodynamics, materials, manufacturing, computer-aided engineering, systems engineering. Some aspects are related to the management, costing, balance sheets, project management, leadership, and so on. So I become very versatile, not only in the one area, but also in the various areas to make yourself capable to deal with many different fields of industries, or you may go into research, but you'll be very versatile to deal with any sort of different sort of projects and so on. You become very aware about what to do to design a spacecraft or aircraft with this awareness of requirements. Sometimes we call it design specifications or design brief. What needs to be done, what needs to be designed. You have this awareness of how to design things with those awareness, sometimes to do with the rules and regulations. If you speak about commercial aircraft, we do have FAA regulations, so you have to design something within that regulations. Environment is another thing. We do talk about pollutions in the air, noise levels. We do have environmental concerns these days. So we do have this kind of awareness in order to design the project or design this product or systems according to that. So with this versatility and awareness, of course, you apply your theoretical knowledge that you learn throughout the BEng, MEng program or MSc. And then together with theoretical knowledge, you have opportunities to do things with a practical sense. A lot of design activities within the individual and in the group to have this kind of a balance between theoretical knowledge and practical knowledge, and put that together as a skill to be versatile as you complete your aerospace program with us. Who teaches you during the program? This is a kind of quick overview to our academic staff for aerospace. In a nutshell, we do have a lot of staff members coming from, of course, from the local, the UK, but we do have a diversity in our academic staff members. Some are coming from non-EU European continents. Some of them, of course, is EU as well. We do have some academic staff coming from the Asian continents and beyond. So we do have a lot of diversity and with various different sort of expertise and knowledge. This might be of particular interest to you with regards to our aerospace program. This is our subjects or the modules that we have for year one study. So on your left-hand side is the semester one. We call it, let's say, autumn, fall, winter sort of semester. That's been already completed. And on the right-hand side, right there, this is our current spring, summer semester modules that's taking place right now. So we do have 6 modules in the first semester. And as you complete the first semester, then you move on to second semester. And we have 6 modules each. And in total, we have 12 modules, 10 credits. Some are heavily physics related. Some are related to mathematics. Some are let's say, to do with like some practical sessions where you do some design activities such as like engineering design one. You may be doing some kind of glider sort of plane design, making those designs through computer-aided engineering. And then you make the prototype and test it and fly. So you have this theoretical learning exercise as well as the practical exercises. And some are, of course, we do have some sessions on computer modeling and simulations and so on. So if I move on here, this is a typical timetable that we have for the current academic year 2019-2020. We do have their timetable, as you see from here on the left-hand side, Monday to Friday, starting from 9 o'clock in the morning, and sometimes we end at 6 p.m. So some are lecture-based learning. You might go into lecture theater, sit down together with your peers from aerospace, or sometimes it's a cross-disciplinary module. So you might be sitting with other disciplines. These are 50 minutes sessions. But as well as that, we do have, we call it a PC lab sessions, which may be running for over two hours. So you might have those computational sessions to learn about those softwares, to do modeling, simulations, calculations, and so on. That can be done within this, we call it PC lab sessions. We do have some experimental studies, which can be done in laboratories to do some using those equipments to do some kind of inputs to the equipment and take some readings and measurements and do some analysis based on your readings and measurements. So we do have that kind of session as well as PC lab and lecture-based learning. This is a quick glance to what we say the assessment for the year one BEng. So we do have the split between the coursework, assignment-based sort of assessment versus the exam, written paper exam-based assessment. So we do have both assessments for some of the modules. Some are 100% coursework. This is because we do some design exercise, as I mentioned before. We do have 100% exam as well. So it's kind of a combination of the both. But in terms of the percentage ratio, as you can see that for year one, typically speaking, more inclined to be exam-based assessment. But as you progress to second year and third year, this percentage ratio start to vary. And we do have more percentage ratios for the coursework as you go to the final year. I'll show you in a minute. But as you move on to second year, we do have modules like this. It is quite heavily more aerospace specific as you move on to second year. As you can see, some of the modules right there at the top, these are only for aerospace. We do have one or two cross-disciplinary modules, but this will get very small number as you progress to the third year. And the other things to highlight is about the stream modules. We call it further specialization within the umbrella of this aerospace. You can specialize further into, let's say, space stream module. If you have some strong interest in space, you can take a stream module in space, such as rocket space and technology. This is for the space-related subject. So you can learn more about space, learn more about those launch vehicle designs and so on. As well as that, we do have other stream modules for the structural side of things, or those computational areas. If you like to do more structural side of further specialization, you can do so. And one more thing we have is the material stream. So if you like to do more to do with the material within the umbrella aerospace, you can specialize starting from year two. So as we move on to year three, the number of modules will be less compared to first year and second year. You start to do more on this research-based activity. We call it EG353, is a final year research project. This will be supervised by the academic staff member. And so you do your final year project, research project with your supervisor. And this is throughout the semester one, semester two. and this is 30 credit module. And also we have this, we call it EGA 302 is a design activity. You might be doing more sophisticated design of the aircraft or spacecraft. Sometimes we design UAVs, for example. So you do this in a group to design those spacecraft aircraft. So because of that assessment for coursework, for the final year project, design work, and so on and so forth, we do have more ratio for the coursework-based assessment as compared to exam. Just quick overview on the year 4, if this is of your interest. We do have both MEng and MSc program for our aerospace, and some may continue from third year, BEng continue to MEng to do their integrated masters. Some may prefer to do MSc. So we do have both programs available to the students. Quick sort of examples from the students' work. This is the past year students' work on the aircraft design. Some of the specifications, sometimes we use it from AIAA or other sort of institutions. This is the supersonic jets designed by the group of 9 or 10 students for MEng MSc students. They use a lot of computational modeling and methods to understand the performance and behavior of an aircraft. Some are at the cruise speed, or some are at the sort of a landing and etc., to ensure that the aircraft will meet the performance specification of the design brief. Sometimes we do a spacecraft design. This is from last year space group who designed the lunar lander for this NASA design challenge. So we do enter this NASA design challenge competition. And I think this year also we do enter NASA competition design challenge competition for another project. And we again use a lot of computational software to simulate and understand and calculate the sort of orbital maneuvers from the Earth, enter into the lunar orbit, and then do the landing on the lunar surface. So we do those kind of computational analysis, and sometimes also we do some kind of 3D printing to realize their design. I mentioned about the software. So these are typical examples software that we use for aerospace. Starting from SolidWorks, this is a very useful modeling tool for making those aircraft or spacecraft and so on and so forth. You can do very simple sort of stress analysis, putting those boundary conditions and see how the structure will behave and how much sort of response due to these boundary loading conditions and how much sort of deflection that you see from the simulation, for example. We use MATLAB also for numerical computing and simulations. This is useful for generating those numbers based on your those integrations and so on. It's kind of math-based numerical simulation, let's say. We use ANSYS, is another sort of sophisticated simulation tool, apart from the SolidWorks. So if you like to do more sophisticated computer simulation with regards to aerodynamics and so on, we use ANSYS. With regards to space, we use GMAT, General Mission Analysis Tool. This is open source NASA software available to us, and we use that to calculate those orbital calculations and that are useful for space-related projects. You might feel worried about, how can I sort of make progress successfully in duration of your BEng or MEng program, and to ensure that you feel confident about moving forward in your studies. We do have a lot of supporting cafes. These are available during the term times to have informal session with academics or demonstrators. Demonstrators are sometimes a PhD or research academic who can support you throughout your journey of your study. And sometimes it's to do with mathematics and related to computer software. We do have those informal sessions, like a drop-in session without appointment, just make yourself comfortable to come in to those sessions and ask questions about how can I solve these mathematical equations, or how can I sort of enhance your knowledge with regards to SolidWorks and MATLAB. Those staff members and demonstrators are there to guide you through to enhance your knowledge. Sometimes you might get stuck with other science-related subjects. We have Science Cafe for that. In case you get stuck with your report writing, let's say those laboratory work report, or writing essay-related type of things, we do sort of give support for the writing, for example. If you're interested in virtual reality, that's also available. We have VR Cafe available to the students to learn about how can I utilize the VR to generate some results or do some analysis on the designs in terms of the VR. So we do have VR Cafe as well. Alongside of teaching and learning, we do have various sort of platform for the students. First up is a hands-on flying experience. We take some students to a local airport, like Cardiff Airport in this kind of premises, to have this kind of a small aircraft sort of flying experience, how the aircraft will behave in certain circumstances, and you feel the capability of the aircraft basically from this flying experience. We do participate in extracurricular activities. For example, we do have a Formula student team who does enter national and also international competitions. And by all means, as an aerospace engineer, you can join the team to participate in this national and international competition. We do take students to industrial site visits, and as well as that, we do have employability team-led College of Engineering mentoring scheme support. We do have opportunities to travel. I mentioned about partner university in Texas A&M. You can have opportunities to travel overseas to do your study over there and come back in to complete your study. I mentioned briefly about the Bloodhounds project. We do have some ambassadors, and we do have academic staff members who are leading in this Bloodhound project. And also we do have some academic staff who are also leading in aspects of space engineering. So quickly go through that. One thing to mention about this competition, we entered this Merlin Flight Sim competition last year. This has been going on for several years. We do participate in this competition pretty much every year. Last year, this was held at the University of Manchester. And then we compete against those universities in the UK, as well as university from Amsterdam in the Netherlands, and also Daytona University in the US. So it's a good sort of opportunity for students to present their ideas and thoughts and designs, and hopefully they will win, of course, this competition. So last year, we entered this competition together with the students, and students presented their rotorcraft design. This is actually a high mountain sort of range rescue rotorcraft. This has been used for, let's say, Himalayas, 30,000 feet sort of environments and conditions. And they model and simulated this rotorcraft capability on the flight simulator, and it's been tested by the ex-pilots from the commercial company, and we managed to win this first prize for innovation. So it is a very good sort of platform, we feel, that for students to have opportunity to present, have opportunity to feel the some kind of extra sort of insights and knowledge that they gain from this competition. I mentioned about industrial site visits. I do take some of the students to industrial site visits. One of the picture in the center, this has been taken at GE Aviations in Wales. I took about 20 students to GE Aviations. This was, I think was in November. We bring them there to learn about what's going to be like to be an aerospace engineer. Sometimes we take them to Rolls-Royce, to Derby or the Bristol Rolls-Royce operation sites. And also we do have a mentoring scheme. This is an employability-led mentoring scheme. This is a support for students who are thinking about entering into industry. And we do have support such as the mock-up interviews, CV writings, and how to prepare and how to get connected with various companies and so on. So we do have this mentoring scheme available to aerospace engineering students. Just a little bit about space engineering. I personally have done a space program before, and I'm sort of one of the person leading in this space stream. And this year, one of the MEng aerospace engineering students, he has been selected to take this European Space Agency Academy Clean Space Training course. This was held in February this year in Bristol, in Brussels, in Belgium. And so we had this opportunity to send the students to this very prestigious ESAR training course. And so a lot of those space enthusiasts who like to do something space, they have opportunities like this for the enhancement of their knowledge in space. And speaking of UK space as a whole, I don't know if you know, but we do have a lot of things coming up. The first picture on the right-hand side of the top, this is the reaction engines that has been taken at the space conference held in Newport last year. We do have a lot of programs also coming up from the Airbus UK, designed this Mars rover units designed by the Airbus UK, and this is going to be launched by the European launch program, hopefully about 1 or 2 years time. So we do have this kind of a platform to support space enthusiasts, and we hope to send as many students as possible to those space sectors. So this is kind of a quick wrap up and summary. So this is the website to obtain the 2020-2021 undergraduate prospectus. This is available online in the following website. And if you'd like to find out more, once again, about aerospace engineering, it's found on the page 68 of this prospectus. So in case you like to know more about aerospace engineering, further information or general information as such can be found on this page. Thank you very, very much for listening to this introductory talk on aerospace engineering. And my name is Dr. Kiyo Wada. I'm the aerospace engineering admission tutor. In case you'd like to get in touch with myself or colleagues, I'm more than happy to answer any queries or doubts. We do very much hope to see you in the near future. Thank you very much.